Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on integrals of trig functions with exponents is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will be discussing integrals of sine and cosine squared functions, integrals of sine and cosine cubed functions, integrals of sine and cosine to the fourth functions, integrals of sine and cosine to the fifth functions, and generalized integration strategies. We'll start with the integral of sine squared. To solve this integral, we need the identity sine squared of x equals 1 minus cosine 2x over 2. When we replace this identity, we can start by removing the 1/2 from the integral as a constant, leaving us 1/2 the integral of 1 minus cosine 2x dx. We can then separate the integral at the minus sign. The integral of dx is x plus c, and we'll call that one c1. The integral of cosine 2x can be found by setting u equal to 2x, which makes du equal to 2 dx, or dx equals 1/2 du. We can then rewrite the integral as 1/2 cosine u du, which is 1/2 sine u, or 1/2 sine 2x plus c2. When we simplify and combine our constants, we get x over 2 minus sine 2x over 4 plus c. Now let's find the integral of cosine squared x dx. Here we use an identity similar to our last problem. Cosine squared x equals 1 plus cosine 2x over 2. We substitute this integral. We then can remove 1/2 as a constant, leaving us 1/2 the integral of 1 plus cosine 2x dx. We separate the integral at the plus sign. This is very similar to our last problem, so we take the integral and get 1/2 times the quantity of x plus c1 plus 1/2 sine 2x plus c2. When we simplify and combine our constants, we get the final answer, x over 2 plus sine 2x over 4 plus c. Next, let's take the integral of sine cubed x. Here we separate the sine into sine squared x times sine x, so we can use the identity sine squared x plus cosine squared x equals 1, or sine squared x equals 1 minus cosine squared x. We substitute for sine squared x, giving us the integral of the quantity of 1 minus cosine squared x times sine x dx. Let u equal cosine x, and then du would be minus sine x dx. When we substitute, we get the integral of 1 minus u squared times negative du. If we distribute the negative sign, we'll get a simpler arrangement, the integral of u squared minus 1 du. We can now separate at the minus sign, then take the integral to get u cubed over 3 minus u plus c. We then substitute back in for our final answer, cosine cubed x over 3 minus cosine x plus c. We can use a similar strategy to solve the integral of cosine cubed x dx. Again, we split the integral into cosine squared x times cosine x dx. Then use the identity sine squared x plus cosine squared x equals 1, or cosine squared x equals 1 minus sine squared x. We replace cosine squared in the integral, then set u equal to sine x, which makes du equal to cosine x dx. This gives us the integral of 1 minus u squared du. We split the integral at the minus sign, then take both integrals to get u minus u cubed over 3 plus c. When we substitute back in, we get our final answer, sine x minus sine cubed x over 3 plus c. Let's next take the integral of sine to the fourth x dx. Here we'll need the same identity from the sine squared problem. Sine squared x equals 1 minus cosine 2x over 2. Since this is sine to the fourth, when we substitute, we get the integral with this identity squared. When we square the denominator, we arrive at the constant 1/4, which can be removed from the integral. We are then left to FOIL the numerator. The result is 1/4 times the integral of 1 minus 2 cosine 2x plus cosine squared 2x dx. Next, we separate the integral at the minus sign and plus sign. Note, we also move the constant 2 outside of the second integral, then use the identity cosine squared x equals 1 plus cosine 2x over 2, except this time we have cosine squared 2x, which is equal to 1 plus cosine 2 times 2x over 2, or the integral of 1 plus cosine 4x over 2 dx. We will now take each integral individually and save the constant c for the end. The integral of dx is x. We then bring down the minus 2, then find the integral of cosine 2x. Set u equal to 2x, making du equal to 2 dx. This gives us the integral of 1/2 cosine u du. We take the integral to get sine u over 2, then replace our substitution to get sine 2x over 2. Next, let us separate the third integral, 1 plus cosine 4x over 2 dx, into 1/2 times the quantity of the integral of dx plus the integral of cosine 4x. Next, we take the two remaining integrals. The integral of dx is x. The integral of cosine 4x can be found with a similar use substitution as before to get sine 4x over 4. We then simplify the inner parentheses to x over 2 plus sine 4x over 8. We then combine the like terms to get 1/4 times the quantity of 3x over 2 minus sine 2x plus sine 4x over 8. Distribute our 1/4 to get a final answer, 3x over 8 minus sine 2x over 4 plus sine 4x over 32 plus c. Let us next take the integral of cosine to the 4th x dx. We can use a similar strategy as we did for sine to the 4th. Here we'll need the same identity from the cosine squared problem. Cosine squared x equals 1 plus cosine 2x over 2. Now when we substitute, we get the integral of 1 plus cosine 2x over 2 quantity squared dx. Again, we can separate 1/4 as a constant and FOIL the numerator to get 1/4 times the integral of 1 plus 2 cosine 2x plus cosine squared 2x dx. Next, we separate the integrals at the plus signs. We can now use the same identity to change the integral of cosine squared 2x dx into the integral of 1 plus cosine 4x over 2 dx. Now we can take each individual integral and save the constant c for the end. The integral of dx is x. Using u substitution, 2 times the integral of cosine 2x dx is 2 times the quantity of sine 2x over 2. Next, let us separate the integral of 1 plus cosine 4x over 2 dx into 1/2 times the quantity of the integral of dx plus the integral of cosine 4x dx. This integral is 1/2 times the quantity of x plus sine 4x over 4. Next, we simplify the inner parentheses to get 1/4 times the quantity of x plus sine 2x plus x over 2 plus sine 4x over 8. We then combine the like terms to get 1/4 times the quantity of 3x over 2 plus sine 2x plus sine 4x over 8. We then distribute our 1/4 to get the final answer, 3x over 8 plus sine 2x over 4 plus sine 4x over 32 plus c. We can also solve the integral of sine to the 5th x dx in a similar way as we solved the cubed problems. We separate the integral into sine to the 4th x times sine x dx. We then use the identity sine squared x plus cosine squared x equals 1, or sine squared x equals 1 minus cosine squared x. We make our substitution, which gives us the integral of 1 minus cosine squared x quantity squared times sine x dx. Next, we let u equal cosine x and du equal negative sine x dx. When we substitute, we get the integral of 1 minus u squared quantity squared times negative du. We move the negative to the front and FOIL the binomial squared to get the integral of negative the quantity of 1 minus 2u squared plus u to the 4th du. We take the integral to get negative u plus 2u to the 3rd over 3 minus u to the 5th over 5 plus c. We then substitute back for our final answer, negative cosine x plus 2 cosine cubed x over 3 minus cosine to the 5th x over 5 plus c. Let's now solve the integral of cosine to the 5th x dx, but this time we'll solve it as a definite integral from 0 to pi over 2. In a similar way we solve the sine to the 5th, we separate the integral into cosine to the 4th times cosine x dx. Then we use the identity sine squared x plus cosine squared x equals 1, or cosine squared x equals 1 minus sine squared x. We make our substitution, which gives us the integral from 0 to pi over 2 of 1 minus sine squared x quantity squared times cosine x dx. We let u equal sine x and du equal cosine x dx. This changes the boundaries of our integral. Sine 0 is 0 and sine pi over 2 equals 1. When we substitute, we get the integral from 0 to 1 of 1 minus u squared quantity squared times du. We then FOIL the binomial squared to get the integral from 0 to 1 of 1 minus 2u squared plus u to the 4th du. We take the integral to get u minus 2u to the 3rd over 3 plus u to the 5th over 5 evaluated from 0 to 1. This gives us 1 minus 0 minus the quantity of 2 over 3 minus 0 over 3 plus the quantity of 1 over 5 minus 0 over 5. We can simplify to 1 minus 2 over 3 plus 1 over 5, or 8 over 15. We can now generalize an integration strategy that will work for powers of sine and cosine. For sine and cosine to the n, where n is odd, split the trig function and use the form of the identity sine squared x plus cosine squared x equals 1. When n is even, use the identity sine squared x equals 1 minus cosine 2x over 2, and cosine squared x equals 1 plus cosine 2x over 2. And substitute, being careful to leave the identity to the correct power. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.